Dear students, in the last class we have studied about coagulation and Hardy-Skulls rule. Now, let us see some more properties or things colloids, flocculation values, methods of coagulation, coagulation of lyophilic salts, protection, and lastly application of salts or colloidal systems. You know coagulation. What is coagulation? It is the method of precipitation of colloidal system salts by the addition of electrolyte. When you add an electrolyte into the given salt, the salt particles start to settle down. That means precipitation occurs. This process of precipitation of salt by the addition of electrolyte is known as coagulation. See, during coagulation, neutralization of charge on the salt particles takes place by the ions of electrolyte. So, Hardy-Skulls rule states the efficiency of an ion causing coagulation depends upon its valency or the charge carried by that ion. The efficiency of an ion causing coagulation depends upon the charge carried by that ion. Normally, the charge carried by ion will be opposite to that of salt particles. Higher the charge on the ion, higher will be its coagulating power. Higher the charge, higher the coagulating power. Now, let us see this flocculation value. Generally, the coagulating power of an electrolyte or ion is expressed in terms of flocculation value. What is this flocculation value? Flocculation value means it is the minimum concentration of given electrolyte or ion in millimole per liter. Minimum concentration of electrolyte in millimole per liter required to bring about the coagulation of given amount of salt in just 2 hours. Within 2 hours, the minimum concentration in millimole of given electrolyte which causes are used to bring about the coagulation of given amount of salt in 2 hours. See, millimole, you know that mole per liter, it is nothing but molar. Mole per liter is molar. So, it is millimolar. Concentration of electrolyte should be in millimolar. So, minimum concentration which just required in millimole per liter just required to cause the coagulation of given amount of salt in 2 hours is known as flocculation value. Lower the flocculation value, higher will be the coagulating power of that electrolyte, or vice versa. See, Hardy-Skulls rule states higher the charge, greater the coagulation. Charge directly proportional to coagulation. So, higher the charge, higher will be the coagulation. Lower the charge, lower the coagulation. Here in flocculation value, lower the flocculation value of an electrolyte, higher will be its coagulating power, because it requires less amount to cause the coagulation of given amount of salt. So here flocculation value, smaller the flocculation value, higher the coagulating power. So these two are related like that. Hardy-Sculls rule depends on charge. Here flocculation, here coagulation depends upon the charge. Here coagulation depends upon the concentration. Okay. Next one is methods of coagulation. Let us see the different methods to bring about the coagulation. One method you already seen, that is the addition of electrolyte. An addition of electrolyte to salt, coagulation takes place, where neutralization of charge of salt particles takes place by the ions of the added electrolyte. So one method is adding electrolyte. Coagulation means spoiling of salt, that is conversion of salt into precipitate, that is. So one method is adding electrolyte. When you add electrolyte into salt, precipitation takes place. Another method is, of course there are other methods other than coagulation, that is adding electrolyte method. Prolonged or long time dialysis. Long time dialysis. Prolonged dialysis leads to decrease of stability. So long time dialysis leads to formation of ultra pure salt. Ultra pure salts are highly unstable, very quickly undergo coagulation. Next one is, see, consider a positive salt. Positive salt. Positive salt is one in which all salt particles are carrying positive charge. Consider another salt carrying negative charge, that is negative salt. Example for negative salt is, it is arsenic sulfide salt. It is negative salt. Metal salts prepared by Briggs arc method. This one, positive salt, say ferric hydroxide salt, in which more amount of ferric hydroxide, ferric chloride is added, or hydrated ferric oxide. Now, to this positive salt, add a negative salt. On adding a negative salt into a positive salt, the charge, actually both the salt particles, so particles of both salt, undergo neutralization of their charge and coagulate. So positively charged salt coagulate, negatively charged salt also coagulate. That means on addition of a negatively charged salt into positively charged salt or vice versa, both the salts undergo coagulation due to mutual neutralization of charges. Such process or method is known as mutual coagulation. One method is addition of electrolyte. That's common method. Another one is long time dialysis. Next one, mutual coagulation. Next one, see, if you subject salt for electrophoresis process, that means if you pass current through given salt, on passing current through given salt, the salt particles migrate either towards cathode or anode. This method of movement of salt particles under the influence of applied electric field is known as electrophoresis. During electrophoresis, negatively charged salt particles move towards anode and positively charged salt particles move towards cathode. Okay? At the respective electrodes, the salt particles lose their charges or their charge it neutralized. As the result, coagulation, aggregation of salt particles, association of salt particles takes place, which leads to the coagulation. So, another method is electrophoresis process. So, by electrophoresis method also we can bring the coagulation. Okay? See, these are some methods of coagulation of salts. Next bit is, let us see the coagulation of lyophilic salts. We know there are two types of salts, lyophilic, lyophobic. Lyophilic salts and lyophobic salts. Lyophilic salts are solvent loving salts or liking salts. Lyophobic salts are solvent hating salts. Okay, you know this difference. Another one is lyophilic salts are more stable. Lyophobic salts are less stable. Lyophilic salts are more stable, lyophobic salts are less stable. Here, one interesting thing lies, in case of lyophilic salts, say lyophilic salts are solvent loving salts. Okay, lyophobic salts are hating, solvent hating. More stable lyophilic, less stable lyophobic. See here, addition of electrolyte, addition of small amount of electrolyte has no effect, does not cause any change. Addition of small amount of electrolyte will not bring coagulation or change. Here, addition of even a little amount of electrolyte, small amount of electrolyte will bring coagulation, immediate coagulation. Okay. Now, let us see that point or characteristic responsible for these properties of lyophilic salts. You know, lyophilic salts are solvent loving salts. Lyophilic salts are solvent loving salts. In lyophilic salt, we just consider this is the salt particle carrying either positive or negative immaterial. This salt particle is surrounded by a number of layers of solvent. Solvent, it is salt particle. These are solvent particles or layer. That is medium, dispersion medium. Dispersion medium, number of dispersion medium are present around each salt particle, because here this salt particle is solvent loving salt. So, solvent forms a sheath of protective layers around salt particle. Here, this lyophobic salt particle, which is solvent lubricating salt. There is no such protective layers of solvent around lyophobic salt particles. That means lyophobic salt particles are somewhat exposed, whereas lyophilic salt particles are not exposed. Okay, you just keep this point in mind. Next, on addition of electrolyte, the electrolyte cannot attack the salt particles directly because there are a number of protective layers of solvent around each salt particles. Here there is no such protective layers, so on addition of electrolyte directly attack the salt particles and bring the coagulation. That's why lyophobic salts are less stable, lyophilic salts are more stable. Another point, on addition of little amount of electrolyte, keep it in mind, little amount of electrolyte. On addition of little amount of electrolyte into lyophilic salt will not bring coagulation because there exist a number of protective layers of solvent around the salt particles. Okay. Now, if you add more amount of electrolyte, no doubt, even in the case of lyophilic salt, coagulation takes place. On addition of large amount of electrolyte. On addition of large amount of electrolyte, these protective layers of solvent may be removed. That means even the lyophilic salts can be coagulated by adding even a little amount of electrolyte. Keep it in mind, even a little amount of electrolyte by removing the solvent layers. If you remove the solvent layers or protective layers present around the lyophilic salt particles by one or the other method, then even addition of little amount of electrolyte will bring the coagulation. Case of lyophilic salt. See, to remove the solvent, so for example, if salt is hydrophilic salt is one which is water loving salt. So in hydrophilic salt, around the salt particles there are layers of water. If you add acetone or alcohol, acetone or alcohol removes the water. That means acetone or alcohol absorbs water present around the salt particles. Okay, then the salt particle is exposed. On addition of little amount of electrolyte, the salt particles also undergo coagulation. That is important thing. So even in the case of lyophilic salts, we can bring the coagulation by adding a little amount of electrolyte only when the protective solvent layers are removed by using suitable chemical agents. So in case of hydrophilic salts, if we use acetone or alcohol before adding small amount of electrolyte into lyophilic salt, even lyophilic salts undergo coagulation. So this is the method of coagulation of lyophilic salts. See, if you are friendly, very much friendly, then we'll have number of friends, that close friends around you. ನೀವು ತುಂಬ ಫ್ರೆಂಡ್ಲಿ ಆಗಿದ್ದರೆ ನಿಮ್ಮ ಸುತ್ತ ತುಂಬ ಜನ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗಳಿರ್ತಾರೆ. ನೀವು ಫ್ರೆಂಡ್ಲಿ ಆಗಿಲ್ಲ ಅಂದರೆ ನಿಮಗೆ ಯಾರೂ ಫ್ರೆಂಡ್ಸ್ ಇರಲ್ಲ, ನಿಮ್ಮ ಸುತ್ತ ಯಾರೂ ಇರಲ್ಲ. ನೀವು ಫ್ರೆಂಡ್ಲಿ ಆಗಿದ್ದಾಗ ನಿಮ್ಮ ಸುತ್ತ ಫ್ರೆಂಡ್ಸ್ ಇರೋರು ಏನು ಮಾಡ್ತಾರೆ, ನಿಮ್ಮನ್ನು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡ್ತಿರ್ತಾರೆ ಫ್ರಮ್ ಯುವರ್ ರೈವಲ್ಸ್ ಆರ್ ಎನಿಮೀಸ್. ಹಾಗಿಲ್ಲ ಅಂದರೆ ಬೇರೆ ನಿಮ್ಮ ಎನಿಮೀಸ್ ಡೈರೆಕ್ಟಾಗಿ ನಿಮ್ಮನ್ನು ಅಟ್ಯಾಕ್ ಮಾಡ್ಬೋದು. ನಿಮ್ಮ ಫ್ರೆಂಡ್ಲಿ ಆಗಿಲ್ಲ ಅಂದರೆ ಲಯೋಫೋಬಿಕ್ ಆಗಿರ್ತೀರ, ಬೇರೆಯವ್ರು ನಿಮ್ಮನ್ನು ಈಸಿಯಾಗಿ ಅಟ್ಯಾಕ್ ಮಾಡ್ತಾರೆ. ನೀವು ಫ್ರೆಂಡ್ಲಿ ಆಗಿದ್ದರೆ ನಿಮ್ಮ ಸುತ್ತ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಒಂದು ಲೇಯರ್ಸ್ ಇರುತ್ತೆ, ಸರೌಂಡಿಂಗ್ ಇರುತ್ತೆ, ಆಗ ಯಾರೂ ನಿಮ್ಮನ್ನು ಅಟ್ಯಾಕ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಅವಾಗ ನೀವು ಲಯೋಫಿಲಿಕ್ ಸಾಲ್ ಆಗಿರ್ತೀರ. ದಟ್ ಈಸ್ ಒನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್. ನೆಕ್ಸ್ಟ್ ಬಿಟ್ ಈಸ್ ಪ್ರೊಟೆಕ್ಷನ್. Lyophilic salts are more stable than lyophobic salts. Lyophilic salts, more stability of lyophilic salt is mainly due to the presence of number of layers of solvent, protective layers of solvent around each salt particles. In case of lyophobic salts, there is no such protective layers because they are solvent hating, disliking salts. Okay. Now, if you add a little amount of lyophilic salt into a lyophobic salt, see the interesting thing. An addition of little amount of electrolyte into lyophobic salt will cause immediate coagulation of lyophobic salt. Immediate coagulation takes place. It is not so in the case of lyophilic salt. If you add a little amount of electrolyte into lyophilic salt, coagulation will not occur because there are some protective layers around the salt particles. Okay. So little amount of electrolyte add ಮಾಡಿದ್ರೆ lyophilic salt immediate precipitate ಆಗಿಬಿಡುತ್ತೆ, coagulate ಆಗುತ್ತೆ. Lyophilic salt coagulate ಆಗಲ್ಲ. Okay. If you add a little amount of lyophilic salt into a lyophobic salt, see, if you add a little amount of lyophilic salt into a lyophobic salt, then if you add a little amount of electrolyte, even your lyophobic salt will not undergo coagulation. That's the interesting thing. Okay. This method, that means before adding electrolyte, little amount of electrolyte into lyophobic salt, if you add little amount of lyophilic salt, little amount of lyophilic salt, then lyophobic salt will no longer be coagulated. That is interesting thing. You just consider this is a lyophobic salt particle. Lyophobic salt particle. To this, if you add a little amount of electrolyte, it undergoes coagulation, immediate coagulation because of neutralization of charge present on the salt particles. Okay. Now, before adding little amount of electrolyte into this lyophobic salt, if you add a little amount of lyophilic salt add ಮಾಡಿದ್ರೆ lyophilic salt will form protective layers around the lyophobic salt particles. See, these are lyophilic salt particles layer. Okay. So, added lyophilic salt forms a protective layer around lyophobic salt. As the result, the added electrolyte does not attack directly on the lyophobic salt. Okay. To cause the coagulation of lyophobic salt, first the added electrolyte must break the lyophilic salt layers, must precipitize lyophilic salt, then must attack lyophobic salt particles. Okay. So, by this way we can protect the lyophobic salt from the coagulation or precipitation, the addition of electrolyte. This phenomenon is our process of protection of lyophobic salt from coagulation with addition of electrolyte using suitable amount of lyophilic salt is known as protection. The lyophilic salt acts as protective layer or protective colloid. Lyophilic salt generally acts as protective colloid to protect lyophobic salts from coagulation due to the addition of electrolyte. Okay, this is known as protection. The protective power of lyophilic salt varies from salt to salt. Protective power varies from salt to salt. Generally, the protective power of lyophilic salt expressed in terms of gold number. The protective power of lyophilic salt generally expressed in terms of gold number or Zygmonde number. Gold number or Zygmonde number. Then what is this gold number or Zygmonde number? Gold number means it is the number of milligram. Keep it in mind, milligram. Number of milligram of protective colloid. Protective colloid means lyophilic colloid required to prevent the coagulation of 10 ml of standard gold salt. Standard gold salt, generally known as red salt of gold, okay, in which gold particles are in very small state. Say number of milligram of protective colloid required to prevent the coagulation of 10 ml of standard gold salt or red gold salt by the addition of 1 ml of 10% sodium chloride solution or 10 ml of 1% sodium chloride solution. It is known as gold number. See here, you have 10 ml of gold salt, and to this you are going to add 1 ml of 10% sodium chloride solution. During this process, to prevent the coagulation of this gold salt, how much amount of protective colloid, that is lyophilic colloid, in milligram should be added. That amount of protective colloid required is known as gold number. Gold number means it is the number of milligram of protective colloid that required to prevent the coagulation of 10 ml of standard gold salt by the addition of 1 ml of 10% sodium chloride solution, or you can say 10 ml of 1% sodium chloride solution. See, gold number of starch is 25. Gold number of starch is 25. It means 25 milligram of starch is required to prevent the coagulation of 10 ml of gold salt by the addition of 1 ml of 10% sodium chloride solution. That means before adding this amount of sodium chloride solution, if you add 25 milligram of 10 ml of gold salt, then on addition of 1 ml of 10% sodium chloride solution, this gold salt will no longer be precipitized. Gold salt will not be coagulated. This is the meaning of gold number. Smaller the gold number, higher will be the protective power. Smaller the gold number, higher will be the protective power of protective colloids or lyophilic colloids. Say 25 milligram is the gold, 25 is the gold number of starch. Okay. 1 is the albumin. If 1 is the gold number of albumin, then you can say albumin has more protective power than starch. Okay. Albumin gives higher protection than starch because albumin has lower gold number. That is about protection, protective colloids, gold number, etc. Next, we shall see the application, emulsion, another type of colloidal system, that is emulsion. Okay. Yes.